Good morning, students. Today is our topic basis on gradient. Actually, we in last lecture we discussed about the gradient and taken a simple problem of basis on gradient. But today we are taking the application of gradient to find out the direction derivative. In a given direction, the gradient how to work. This will be shown here. A very important example. Okay, here I am giving the example. See the temperature at any point in the space t a function. This is given a function which is scalar. You see here is no discussion about the direction of the function. Determine the derivative. Again, I last told you when the discussion about the derivative and direction derivative we will discuss about the gradient, the matter of the gradient. In the vector, this one. This is the direction. We should be calculate a function, scalar function in this direction. So, here the matter of gradient. So, given t is equal to xy plus yz plus z. This is given. Okay, now we have to find the change. So, gradient t I del upon del x, j del upon del y, k del upon del z, xy plus yz plus z. Okay? Now I del upon del x, xy yz plus z plus j del upon del y, xy plus yz plus zx plus k del upon del z, xy yz plus z. Okay, students? Now I become y plus here this term is 0 plus z. We get the x plus j x plus z 0 and k 0 plus y plus. Okay. Now gradient at point 1 1. So 2i plus 2j plus 2k. Put the value of x, y, z 1 1 1. This is the question. Now he is asking about the direction derivative. So we need the unit vector of this direction. So the derivative of t in the direction 3i minus 4j. So we denote by d u t to a gradient of t and kept unit vector. So 2i plus 2j plus 2k dot 3i minus 4j upon 9 plus 3. Okay? A vector A upon norm of A. So 2i plus 2j plus 2k. Here we apply and cat is equal to this formula. Okay? So I write it. 3i minus 4j upon. Now This is a dot product. So we can write I to I 1, j to j. So become 4 j to j minus 8 plus, here in the k not available k component, so it will be 0 minus 8 upon 5, to become minus 8. This is the answer of oh sorry, here is 6. 3, so become 12. Okay students, this is very important example to understand the concept of gradient. Sometimes this type of question asked in the exam. Now further we are taking the topic here, dot product. Now come to the topic of divergence. This is related to the dot product. So I want to start today. What is the meaning of divergence? Basically, divergence, if we are talk about the fluid compressible and non-compressible, then let and P vector divergence. Let and be a vector space or vector element, vector space or element, and F1, F2, F3 are the component in X, Y, Z direction. So we can write F F1 I cap, F2 J cap, F3. Okay. So now divergence. Divergence of F. Divergence of F, I del upon del X, I del upon del Y, J, K del upon del Z, dot product with F1I, F2J, F3. Okay, here is the dot product with a vector quantity. So we know dot product of I dot I is equal to 1, I dot j is equal to 0. Okay, and j dot k is equal to 0. Actually, I j 0. Okay, so we can write here del upon del F, F1, del F2 upon del Y, del F3 upon. This is called the divergence of F. Here you observe that this quantity is scalar quantity. So here the comparison with the gradient change is scalar in a vector form and divergence change vector in a scalar form. Okay student, this is the concept of divergence. Very important concept of divergence. That very simple. F is a vector function. Vector space not here you conclude function. function and f1, f2, f3 is a component of f, then divergence is the dot product. Okay, dot product with the f, and this will become a scalar quantity, scalar function of scalar. Okay, now we take an example where f is 2xyi plus 3x2yj plus z square k. So find the divergence of f at simply point 1 1. Okay. Now, what is the definition of divergence? Divergence f is equal to I del upon del x, j del upon del y, k del upon del z, dot is the dot product with 2xyi 3x2yj plus z square. Okay, so I to I del upon del x 2x plus del upon del y 3x2y plus del upon del z. Okay friends, now 2y plus 3x square plus this is the divergence at point 1 1 1. Okay, need not to write that at 1 1 1 only. Leave it. Okay, need not, because divergence gives a scalar function. I want to explain that divergence of f give you a scalar function. So this function is not vector, this is a scalar function.